And then there's that 85, 380 rather. All right, this side on this over here with Carlos and Ashley. What is the base?
The base is 5. No treble.
Base 5. And then on this side, what's the switch?
380 with x is going to be x above 5 and equals 380.
Correct.
Boys!
Base and switch. Enough of the test is going to be, they'll have the in log form. You'll put in exponential form, and then there's something to do after that. But going from this first step to the second step is the big deal. If you can't do this, then anything else they want you to do won't even matter. So that's why we're base and switch on those. And so for now, we're going to put those away on my thank you. On B, give me the base, 1.5. Someone else, give me the switch. That side, someone give me the base, please.
Well, no, that one's switched out again. But
what's on your paper?
Log 7x equals 3.
And let me say this, just the way she said that. Officially,
I know, I should like sing it.
When you read it out loud, it's log base 7 of x equals 3. Let's see if this thing will slide down. All right, on that side, someone give me the base.
7.
Somebody else give me the switch, or let's in this case, since those two already answered, what is the switch on this one?
3.
All right, no big deal, no big deal. All right, on here you should have this top row marked as standard 3.
Correct.
It turns out that the middle section, which is slightly different than the top section, also belongs to standard 3. So if you could, you can also mark this guy as standard 3. Don't eat them all up because we're going to use them again for space practice. That is, I want you to rewrite just the first time in the second group in the exponential form. Exponential form is when we take the word log away and then you just rewrite it. So write the base and then so right here, just like on the board, you can write it down. Come on in. So again, on that middle section, base and switch, please. Base and switch. And by writing base and switch, now don't do.
So basically everything.
Here it comes. So someone tell me the base on this one, please. And the switch.
8. 3.
Thomas, we finished this page with a counter page for you.
We may or may not, depending on how many pages we do and how much is involved. But it's so easy that I don't know. But we'll see when we get there. All right, take a look here. Here's the big part on this problem. In standard 3, this will be the easiest version of this. How do you know when you're doing the easiest version? When the x is on one side alone, after you write an exponential form, and on this side you have the 7 to the 3rd power. Let me get your calculators. You'll just
put 4.
So again, type in 7 raised to the 3rd power using the caret button, which is right below the clear button, all the way to the right, below the gray arrows. And because this section is going to be so easy, still in standard 3, I am going to let you write an x equals whatever that answer is. Write an x equals whatever that answer is for that one. In a second, I'll ask for that answer. All right, here it comes. Someone give me the answer. X equals?
43.
3, 4, 3. I put a 5 by accident. That's it. I'm mantra for the base and switch. I'll write that base first, switch, and then put it into the calculator. Don't do the 3rd and 4th one. I know you probably can. The idea is from day to day, just let them redo 1 or 2. And the idea is space practice. If we do one each time of each kind, the idea is when we get to the test, it should still be there instead of just doing it on the first day and never doing it again until the test.
I want to buy it.
Someone tell me the base, please.
2 Spotify. I still have to pay for it.
2.
Thank you. And the switch.
That's true. And you can play
Thank
with it.
you.
Something.
Final answer on this one was a
64.
64. All right, do me a favor.
I have a pretty much-
Just the third one on the top section. We're leaving the easy ones. Going back to medium. All right, just a reminder, because you're about to do the full version of it. I'm going to do the long version. I'm going to remind you of the short version. You can decide which one you'll do on the third one. Again, we know the base of the fiber.
What?
The switch. We got the X. We got the 125. So that you'll have heard the real version one more time before I do the fast version. If ever X is floating in the air like a balloon, you need to tie a log onto it to bring it down. Anytime the exponent is floating up high, you tie a log onto it to bring it down. How do you do that? You just tie the log on. What you do to one side, you must do to the other. You tie the log on. And what that allows is for the X that's up high to come down. That's why you tie it on in the first place, because you need X from in the ceiling. You want it with X log 5 equals that log 125. So that part's not hard. To get the X from the sky, tie a log onto it, it drags it down. Once you drag it down, now you just need to isolate the X, get the X alone. What do you do to get the X alone? You divide the log 5 on both sides, because it's X times log, so to get rid of that, log 5, what you do on one side, you must do on the other. And this is where I want everyone just to plug in their calculator one last time. And make sure you put the parenthesis after the 5 and the 125. Type in log. Where's the log button? What is connected to? What's near it? It's near the number 7. Do log 125 divided by log 5. And then I'm going to start this whole problem all over again on this side over here, just to show the version that you do as a math. You use to it. I'll ask for it. What was that final answer?
3.
It is a 3.
I didn't get 3. I didn't get 3 either.
All right. Did you close off the parenthesis on those 125 and the 5? And as I write this new version, here's the most important part I want to say to you. If you get it where the X is in the exponent, that makes it an exponential form, I just circle an arrow. Circle an arrow. What does that mean? Every single time to solve this one, which is all the same things, it'll turn into a division problem. The 5 and the 125. Hopefully they can see this, the 125. The 5 that I drew the arrow on, and the X that's left over.
You have to flip.
The only difference here when you do the short version, you have to write the word log twice. So the short version, if you know the long version, you don't need the short version. But in the case that you get tired of writing all of this stuff, if X is in the sky, circle it and draw down. The 5 winds up on the bottom, just like the 5 wound up on the bottom. You have to throw in the logs, because anytime there's an X float in the sky, the word log has to show up somewhere.
11.
And voila, you're left with the fast version. Do you need to know the fast version? No, because the long version isn't that long. But just in the case you I want to get used to that, you can do that. All right, do me a favor. What was that problem? As log of something? The one that we just did, was it a 9 and a 729?
Yes. Yeah.
9, 7, 2, 9.
And then make it pop up.
All right, I know they did the base,
No.
and they did the switch. I'm going to do the fast version. I'm going to do the fast version where I just circle, draw down, which leaves me with this red X, the 7 to 9, the 9 on the bottom. As long as I add both logs, then I'm good to go. If you need to write log here, bring it down. It's okay. Some math teachers won't like this fast version, just in case you get another class with log. We'll see if they just let you get the answer. But someone likes to see, like, no, you put a log here and a log here, because log is the inverse, they will say. of an exponent. What does that mean? Well, if you were doing division and you need the inverse of division, what's the inverse of division? Yeah, multiplication, that's how you undo it. Or if it's addition, the inverse of addition is subtraction. That's how you undo subtraction. The inverse of an exponent is?
Exponent. I don't know.
Log.
It's a log. It's a logarithm. This log thing undoes it, and so it brings it down. What did we say the final answer was on this one?
3.
3. Okay.
4.
Now, if your calculator does something odd, as long as you have all the steps, I might be able to give you credit, or I may have you re-show me what you type in, just in case you missed that particular standard, if that was the issue. So for the 30,000, circle that and put a line through it. The 4.5, circle that and put a line through it. We're just checking off the things that are already in the equation, so that when we have to find what this p is going to be, hopefully there's just one number left over that we can use. And in this case, we can see it's going to be the 35,000. Allow me to read this long problem just so it can hurt your brain for just a second. And the idea is this: once you hear this long problem and you hear it on the test, you'll be like, okay, no, I've heard those before. No big deal. Hey, my neighbor Alex owed $30,000 for the brand new car he bought last year. The interest is 4.5%, but he will not start making payments until he is done with his university work. Yeah, no, I wasn't. Alex decides that he decides that the amount he owes, if the amount he owes ever gets $35,000, it'll be too much for him to handle in the monthly payments. If the function for the situation, double underline the word function. Anytime they give you an equation, they'll call it a function. Or they'll say, this problem is being modeled by a function. In other words, we're going to write out an equation for that thing. Let's see. How many payments or years will it take for the amount owed to reach 35,000? Here's the other scary part. Some students are going to see this 35 twice, and then they'll be like, okay, where am I going to put that 2 times? And so what they'll do, they'll put the 35,000 in the place of P, which is the correct place to put it, and then they're going to take that letter T, and believe it or not, they're going to put that 35,000 in the place of the T as well, which is wrong. If you put it there, the question, well, what am I solving for? When am I going to write the log? So in short, once you find it, the T, the letter in the exponent, we need something floating in the sky. If nothing is floating in the sky, then all these exponential problems, these logs, we don't get to use them. All right, let's solve this guy really fast. Remind you about the P version. Let you catch your breath, and then let you taste a little bit of standard 2. There are only 3 standards. So right now, if you're not confused, you're in a good position to pass the test. Which again, maybe next Wednesday, we might get to taste it. So here we go. Let's see. Tell us how you solve this. Someone with a calculator, please tell me what 30,000 divided into 35,000 happens to equal.
1.167.
167. Here comes my 1.045 T. And again, because that T is floating in the air, I'll do the fast version. You can do the longer version. But I circle that T and I draw an arrow down. Why do the simple version for me? I just feel like with all the steps that are there, a student might remember circle and draw down, circle and draw down. The numbers are bigger, but who cares? You have a calculator. They're decimals, but who cares? You have a calculator. That's why we did the easy version, so you get used to just the steps. On the test, yes, they will do the ugly version. So I circle and I draw down. I'm going to rewrite this. I'm going to rewrite this 167 because in the world of math, we try not to do 2 moves on the same line. When a student looks back at their notes, they're like, what? How did... whereas here, you can see clearly. There's 045 with a little song. All right, let's see if I can do it. Can I squeeze it in? All right, so here it comes. 145. 145, and so I'm left on this last line with a 1.67, 1.045 equals a t, and t happens to equal what?
3.5.
3.5. 3.5 years is how long it's going to take for this guy to either pay off his loans or not be able to pay them off
Or
at
get
all.
stuck in crippling debt.
That's right, for the rest of his life.
So you move on to 1.
No one even said, Thomas, you did not write log. Because when you do that move, it only works if the word log is there. And someone say out loud, question really fast, what would actually 1.67 divided by 1.045 actually equal?
I'll tell you.
Let me see, I'd hate it if it equaled 3. Oh, it can't be 3.5. Both numbers are like ones. This would have to be a 3 divided by 1 to get close to 3.5.
So it's not
It would
3.5?
equal 1.116746.
Wait, what's happening right now?
We were just checking to see for the student who forgot to write the word log in front of the position problem. What answer would they actually get? Would it be a 3.5? They get lucky? Or no, would it all mess up?
It would all go downhill, like
Perfect.
crippling debt.
All right.
Like Alex is
All right. Number 1, number 2. Number 1, they tell me what the P of X is. In other words, what to replace. Where's my formula? Can I get my equation? What to replace this P of X with? In this case, it's going to be 1024. All right, let's write it down, get an answer, and move on. I know you already did it, so I'll do it extra fast. Here it comes. I'm going to write over letters. P of X equals the 2 to the X. I'm replacing the P of X with this 1024. 1024 equals that 2 of X. The X is floating in the sky, so what are we going to do? We're going to circle it and draw down. Now, hopefully you can see it's been a week, so even if you have this written, chances are you aren't just remembering it. Here comes the 1024 all over a 2. Hopefully this doesn't feel tricky, and of course I heard it there. And don't forget the logs, otherwise this answer comes out to like 500 and something. But I don't think the answer is going to be 500 and something. I'm going to ask somebody. Log.
It comes out to 512.
It comes out to 10.
No, I mean if you didn't put log.
If you didn't put log 510, but the real answer with the logs is what was it again?
10.
Look at it and see if there's any part of it that this group of numbers that are separated by commas, the 14, 21, 30, the 35 are called a sequence. They've named them that way. If they use that, please identify the sequence. You're like, oh, you mean the numbers separated by commas? Yeah, that's a sequence. There's a thing called a series. Anybody know what would change this to make it a series?
If it was
There's a simple change we can make with the commas to turn those numbers into a series.
fractions.
Fraction. Close, but not exactly. Something we do with the commas.
No.
We remove them.
But then we have to replace them with something. That's right.
Adding.
That is correct. If these same exact numbers, out of vocabulary, just in case they said something about a series to you, this second line, you can write it down. It's not going to be as important as the first line, but you can write it down. The thing that turns that second line into a series is if those commas were plus signs. Usually they'll say something.
What if there was subtraction?
Usually they won't use that, but again, it would probably fall under at least the series label. You'd have to change something else, but there are only 2 choices. So yeah, if we're subtraction, say the word series, and your teacher will be like, well, you're right. All we need is 2, which would be definitely on the right track. All right, here it comes. What do we do to get from the 21, or rather from the 14 to the 21? And then from the 21 to the 25, we're either adding, subtracting, multiplying, or dividing.
Multiplies by 7.
To get from the, I know what you're thinking, though they're going to say it differently.
Because 7 times 2 is 14, 7 times 3 is 21, 7 times 5 is 35.
But I guess the question they're going to ask you is, what do you do to 14 to get it to 21?
You have 7.
Okay. So what you're saying is, right, what do you do to the 21 to get it to the 35?
And
14.
what?
Yeah.
Yep.
Oh,
To go from the 14 to the 35? Oh, shoot. Oh, no.
Oh, yes.
They're missing a line.
4.
Yeah, see this 4 in
you're
here?
missing 6, 2, and 8 and 9.
Oh, my bad.
Was this supposed to be a whole
Well,
chart?
no, and see, that's the problem. This one is supposed to be linear, and the way it was going to be linear, if I would have noticed that they missed that piece, and they missed this piece, is to get to the next number in order to be linear, you always just add the same number. You add a 7 to get to the 21. Do me a favor, squeeze in a 28. Oh, how am I going to squeeze mine in? Oh, I can't believe they missed that.
When you try fast, but you don't succeed.
What is that? What is that?
When you get what you want, but not what you need.
I don't know what that is. So, I'm like, what is that? No, I'll listen some more. All right, so do me a favor. Squeeze yours in like I just squeezed mine in.
There you go.
Okay.
It's like my song when I like do something. I'm like,
Who said that 14 thing? Was that you, Milo?
Yeah.
You were right, but let me ask it now again. What did you do to go from the 21 to the 28?
7.
Yeah.
Tinky Winky.
So this one is a this one is linear. How's it linear? Because you add to get to the next number. All right, so let's do this. Let's actually go ahead and graph the next page.
I don't like it.
Oh, so we're done? Just like that?
We're about to put in these 3 numbers. Like I'm going to take this chart. Yours is side by side. Mine isn't. And this is what that linear equation looks like.
42.
Go ahead and get 3 partners on the table and put those in. They had the 2 and the 14. They had the 3 and the 21. I'm gonna put in the last piece, and I'm gonna see if we can jump forward. Because what I'm trying to get to is the other type of equation that goes with standard 2.
I think one's enough.
Put in at least 3 dots. I have my 3. My 3, there's nothing special about my 3. I'm not sure how we're going to scale
Do
that.
not sell yourself short.
That right
Every
side.
number is special.
Yes.
Wow.
Okay? Numbers are very special.
I hear
I
you.
was actually filling out the 3.
Here it comes. 2, 3, 1, 2, 3, 4. Now this is old school graphing, nothing special about it. But what they're going to show you is when you're graphing an exponential function. Same thing. You get an XY table. The number's going to be weird, but you just put them in, and then you're good to go. So again, what I'm trying to do is make you feel like, okay, no big deal. So that when they give you like the crazy ones, you're like, whoa. You're like, oh, wait. All I do is just put in the dots. This top one I'm going to do 7s, which is a bad idea for this one, but I'm still do it. 7, 14, 21, 28. I'm scaling the y-axis, so at least some of my dots will fit. When you graph the other ones, the exponentials, you're only going to get 2 dots on the y. Here we go. Let's see. 1 and 2 and 14. 3 and 21. And the 4 and 28. I connect the dots, and voila. Old school graphing. Old school graphing on a linear equation, it makes a line.
No nothing.
The exponential before she walks out, it's gonna make like a half of a U, half of a parabola, like we had on Unit 1 graphing. Let's see if we can find one of those. Again, this is standard 2 is all the graphing stuff. So my plan, graph one more and find an ugly problem, and then let that be it for today. Graph one more, find an ugly problem,
What do you mean?
and let that be it for
What
today.
do you mean graph? No number?
See if we can graph another one of these guys that's ugly, and then find it where 77 and 84. On the first page, we didn't add in those last two numbers that would have been sequenced. Go to, again, page, I guess, what is 4. Write down the range as a sequence. And my hope is that the vocabulary, oh, okay, I know what you're saying. Don't write down the domain. And this time I'll actually write down the word range so that someone who misses and didn't know what the range was, they can have that. Now this one won't be linear.
Exponential.
I got it.
So we're going to graph one last one and then try and find an ugly problem so that you can see what those look like. Because the test is pretty intense. Standard 2 is a little intense. So hopefully as we see these problems, you're like, oh, okay, I've seen that before. Okay. All right, I'm writing down my range now. 3, 9, 27. 3, 9, 27. 81, 2, 4, 3, 1. I'll ask the question. Add, subtract, multiply, divide. What do we get from 3 to 9?
Times 3.
Times 3. From 9 to 27? I heard Ashley say it already. Times 3. Anytime you are multiplying to get to the next guy, you have an exponential sequence. So this one is exponential. This is an exponential sequence.
We keep multiplying by 3, it escalates very quickly.
Right, and that's the big deal. If ever you have something that says, how much money do you want? Do you want
Millions of dollars.
you want it linear? You want to increase it from a linear standpoint, or you want to do it exponential? You always choose exponential. That's how when you save money in a bank, you give them $100 today. Unfortunately, though, in 20 years, not tomorrow, that $100 will turn into something like $500,000. Because every time that they are multiplying the percent on it, it gets bigger, then they multiply the percent on the new bigger number. So that same 3, the percent that they're giving you, they multiply on your $100, then on your $9, then your 27, now on that 243, what do we get for the 243? The next guy in line?
729.
Whoa.
Yeah.
Really?
Yeah.
Yes.
And then that 729 turns into 2,100. All right, we're gonna. They tried to graph a little bit of it for you. Unfortunately, they used a yellow dot, which you can see on mine, and it doesn't show that well on yours. Exponential, because they get big so fast. You have to. You only get to graph really 2 of them. Usually the y-intercept, the number for 1 and the number for 2. Do me a favor, write in those coordinates for the ones that they've given you. This is a 1, this is a 2, 3, and I think they actually put it in by just regular numbers, yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in. They put these small graphs, which is hard for you guys to fill in. But here's what I want you to do: 1, 3. Hopefully, I am marking it properly. What is 2's part going to be? 2, what?
9.
Yeah. So 2, 9. When you graph exponential functions, basically, there are going to be 3 points that you will get if you're lucky. 2 for sure, 3 if you're lucky. What are the 2 for sure that you're going to get? You're all going to get the y-intercept, which I'm about to give you that one and show you why it is going to be that answer. And then after that, we'll look for an ugly problem. So we're near the very end now. Thomas, what is the y-intercept going to be? It's going to be 0, 1.
0, 1?
0, 1. I'm going to have you write down why it's going to be 0, 1. And on exponential functions, y will always be 0, 1 for the y-intercept. I'll do it with some 2's, you do it with some 3's, and see if you catch the pattern. They have space down there, they do have space. Here goes, please write down this pattern for me. Here comes the pattern. Why does, well, first let me ask this question over here, see if someone knows the answer. Hey, somebody who has a good memory, you may have seen this before. Anybody know what 2 to the 0 power equals?
0.
Yeah, I heard 1, I heard 0. 1 wins this time.
2 times. I don't know.
Alright, I'm going to show it again. Let me try this one.
It's gonna equal 1, isn't it?
3 to the 0 power equals 1. I'll do one more so you can feel the pattern, but we're going to actually show why. I'll do it with the 3s, you'll do it with the 2s, and that way you won't ever have to do it again. Last question. 4 to the 0.
1.
Alright. Somebody has to be looking thinking like, that doesn't make any sense. That shouldn't 0 be it? Like how does a 2 turn into a 1? Here it comes right down this pattern, so you will have seen it once in your life. Here it comes. Write 3 to the 3rd power. This is going to show why it doesn't. You'll do it once on your own with the 2s. We'll see if we can find that ugly problem, and then thank you for your time. Someone out loud, what is the 3 to the 3rd power? Can you use calculator or your brain?
9. Oh, 27.
27 is going to be it. Next one in line is 3 to the 2nd power. That one is a 9, but watch this. To get from the 27 to the 9, what you have to do is divide by 3. That's how you get down to the next row. 27 divided by 3 is how you get the 9. We're going to try and turn it into this one thing in just a second. So far, 3 to the 3rd power is 27, no big deal. 3 to the 2nd power is 9, no big deal. Here we go. 3 to the 1st power is what?
1.
It is 3.
Oh, wait. Oh, my God.
It's okay. It's okay. Just look at it. And watch this. To get from the 9 down to the 3, again, you divide by 3. That's how you get down to the next row. And here is why. 3 to the 0 power, the next line down. 3 to the 0. We got a 3, we got a 2, we got a 1, we got a 0. Here it comes. 3 to the 0 power equals what? Well, before you answer, watch this. We know to get down to the next row, we have to divide by the same number. And 3 divided by 3 is what?
1.
1. It's 1.
Last one, a quick problem on this one. Somebody try to guess it, but use a little pattern to get it. 3 to the negative 1 power.
Negative 0.
There's
Negative
0.
3.
Your hint, I hear it. So let me say it to this, but don't say it again right now. Your hint is going to be to get to the next line, you always divide by 3.
Oh, negative 3.
So when you divide this number here by 3, what will that next row equal? And they'll keep it as a fraction. Richard said earlier, but it's going to be just a 1 over 3.
Wow.
So that's why, for those who never heard it, that's why a negative exponent will never give you a negative answer. Because negative exponent is just the next guy in line. To get the next row, we divide by 3, but we're not. The point is to go from row to row to row. All you're doing is dividing by the same number. And this row here, which you're about to do right now with the 2s, whenever you go from here to here, you always divide the number by itself, which is why whenever you raise anything to the 0 power, you wind up with just the number 1. Those little extra 3s are dividing. Hey, what does he want you to do before we find an ugly problem trying to get you out of here? He wants you to do the same thing for the 2s. Do me a favor. Do 2 to the 3rd power, 2 to the 2nd power, all the way down to 2 to the negative 1. Just on your own, just to see if you could do it. If they put this on a test and say, please show or prove that 2 to the 0 power equals 1, this is what you would write down. Alright, you all have done great today. We just need to get one ugly graphic problem. See if I can find out why you're doing that. This part, I'm coming around and check mark this one once you're finished there. And then we'll be able to thank you. Let's see if I can find that problem. Let's see if I can find it. See one there. Then let's see one there. All right. We're down to the end. Let's see if I can pause you. Since you're about to set this up, put a box around these three, because you're about to graph a problem that looks just like this. They didn't give you the table, but when you produce your table, these three are the ones you're going to put in on your table to graph it. What is it going to be? And so you're going to flip back and forth. When I come to you, you flip back to this, but for those who have already checked or haven't got to you, go to page 10. Page 10, go ahead and graph. Hey, did we graph the threes? Yeah, we did. Page 10, fill in the table. Fill in the table. Instead of twos, it's going to be, of course, fours. The box 3 problems you see on the board are the 3 that you will use to graph. In other words, put in 4 to the third power, you put that in on your table. Put in 4 to the second power, just like I have on the board. 4 to the first power. 4 to the 0 power. Put in all these powers, but box the 4 that has the 2, the 1, and the 0. Because when it's time for you to graph on page 10, you're only going to graph the ones in the box. So again, when you're putting this on your table, oh shoot, I didn't show you how to put it.
I'm already committing.
On the left side, just put down the actual number of the exponent, in other words. Alright, so maybe I jumped ahead too fast.
Can we keep everything? Because I'm almost done with this and I don't want to keep it.
It's going to be easy for you if you wrote in pencil. So here's the part that I didn't give you. The 3 means this x here. The 2, okay, yeah. Let's see if they can handle it. The 2, the 1, the 0, and the -1. Alright, so I want to come around and check, but some of you may have put on this side 4 to the third power. You may put 4 to the second power. But technically, all you put on this side is, hey, what number am I going to replace x with? So you're near the end, you're near the end. And then you're going to try and graph it on here. You won't even get the 2 on there because it's going to be too big. You're only going to really get 2 of them on there, and the rest you're just trying to sketch it. Let's see if I can get some help from those out there. Someone say what 4 to the third power was.
64.
64. Someone different. What was 4 to the second power?
16.
16. Someone different. What was 4 to the first power?
4.
Thank you. Someone different. The magical one, the most important one. 4 to the 0 power.
4, 1.
All right. And then that last one with the negative exponent.
Oh, so
All right. All right. This was 1/4. The ones I have boxed are the best chances for graphing. Over here, unfortunately, you're just gonna what's the word I'm looking for? You're going to tick, scale it just with regular numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Can I do?
How are we gonna get 64? How are we gonna get 16 on there? We're not. But without doing it 1, 2, 3, 4, the most famous one that I'm going to start would not get to show. And that guy here with the star, he has to show on an exponential function. He is a star. All right, so I'll graph that one and then Let's look at one last ugly problem, then I'm going to thank you for your time. 1, 2, 3, 4, 5. So here we go. I'm doing 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it only gets up to 4 because of the 2. I'm not going to get 16 on there.
Oh, I know.
So while I wanted this top guy to be in there, he's not going to make it. He's just not going to make it. So here it comes. 0, 1, the most famous one right here. He will always be your y-intercept for any exponential function. They all have to go through this point. So let's say you have to graph something like this, and you're like, what? I don't even know what numbers to put. The first thing you do, 0, 1, you win. Whatever 1 is, he's the next guy in line. 1 and 4. What about 2? Well, I can't fit it on there, but the rule is, they're just going to zoom up really high. The question is, what's going to be on this side? It turns out it's going to be like an airplane, where it's going to start on the runway, and then as it gets ready to blast off, it goes right through that point, and through that point right there. They're going to use the word asymptote at some point. Asymptote is going to be the x-axis. That's not the big deal today, but just for some of those who can hear it, it's like I'm planting the seed. They'll say, what is the asymptote of this exponential function? Your answer will be where y equals 0. See, these are your y's.
Oh.
These are your y's. Okay. Y is 1, y is 2, y is 3. If I was going down to the negatives, I'd have to go down from y is 1 to y is 0 on this line. Y is negative 1, y is negative 2. Well, where y is 1 is the equation for this line here. We'll stress that a little bit more because they're going to ask you, please show us the asymptote. For those who have a good memory, you can put it in right now. Fine. For those who are like, whoa, too much. I just want to draw this. Okay. What's the last I'm going to do? The problem before it. We'll try and set that one up, and then that'll be it. Oh, is any questions on graphing? Get a little table, put your little box, get 2 of them, you're a winner. Table, box, winner. The problem before this one is big, long, and ugly. It turns out this guy looks like he is a standard. Is he a standard 3/1? He's kind of a 3/1. Do me a favor. Read the problem. Let it hurt your brain. Your main job is to try and figure out what am I going to replace this f of x with once I write out the problem. Mark off in the paragraph the things that it gave you. This is the last one. So if you do this one, you're at the very end.
If I finish early, can I go?
No, don't do that.
Yeah.
The double is going to be very important. That's where that 2 to the x comes from. If they said triples, it would be 3 to the x. Those are going to be some special words in the problem. And if you're guessing, that's fine. Guess, because I'm going to write on the board. And once I write on the board, we won't solve it this time, so I'm going to remind me to have us solve it next time. We know we're going to divide the 5,000. So what is it that he wants us to do? He wants to write down the equation. All right, let's try and get them out of here. He wants them to write down the equation that they gave him. Hopefully they highlighted it. Hopefully they can go through and cross out the numbers that are already in the equation. The 5 grand, they gave us that, so we don't need that anymore. The doubles, they gave us that, so that's cool. There's only one other number that's floating around that could take the place of the f of x. What number is that?
30.
You know, if I leave this for Wednesday, we probably will forget to do it. I'm going to try and solve it really fast. You can do along with me or tell me what to do. What's the first thing we're going to do, someone?
Divide 5,000.
Divide the 5 grand on both sides. Because we can't circle and draw down until there's only one base and one exponent. Someone calculate that 30 divided by 5 grand?
0.006.
2.006. How do they do that? They do that because they know you have a calculator. They don't care that it's 0.006, and that if you have to divide it by hand, it'd be like a little bit hard. At this point, everyone should be able to do this next move. So I'm going to give you 60 seconds to do this next move. I'll put it on the board, and then I will thank you 60 seconds to do this. And again, the log divided by, we use that negative 7.3, which appears to be the right answer.